Good morning. So for today's topic, we're going to be talking about 4 easy steps in interpreting your ABG. Now, ABG or your atrial blood gas is a very important topic, especially in the board exam, because it is one of the questions that can be very difficult to analyze and to answer. So let's proceed. So first things first, we have to identify the normal values. Now, in your ABG, there's three factors to consider. You have your pH, you have your bicarb, and you have your PaCO2. No? So mostly, I just take a look at these three factors or three elements. So the normal values would be 7.35 for the pH, and then we have until 7.45. So we have bicarb is 22, 2, we have here 26, and then for the PaCO2, we have 35 to 45. Now, as you can see, I placed here a gap in the middle. So this is the normal values, but we have to identify the median. No? So median will be the value in the middle. So we have 7.4, T, we have 24, and we have our 40 here. No? So in terms of arrows, so we need to also identify the arrows for your ABG, normal values now for the pH. So this is considered any value 7.41 above will be considered as arrow up. You'll all put an arrow here up, and 7.39 to 7.35 will be all arrow down, right? So means that this value here is the middle, right? So once you have identified the normal values, let's proceed to the 4 easy steps. Now, first step will be to identify if the problem is metabolic or respiratory problem. So we will discuss that in a while. Next, we have to identify if it is acidosis or alkalosis. Number 3, we have to identify if it is compensatory or uncompensatory. Now, if it is compensatory, you proceed to step number 4, which is you identify if it is partial or fully compensatory. Because if in number 3 step, it is already uncompensatory, there is no need to anymore to identify if it is partial or fully because it is already uncompensating. All right. So that is your 4th step. Let's proceed to the first step. Now, identifying the metabolic or respiratory, if it is metabolic or respiratory problem, we have to use Rome. I know that you are familiar with Rome, so we have Rome. What does Rome mean? We have respiratory opposite, and we have metabolic equal. So what do you mean by respiratory opposite and metabolic equal? This talks about the arrows that we made earlier, right? So as you can see, we have the arrows here. Now, in step number 1, you have to identify if respiratory opposite. So what do you mean by opposite? So when you say respi, we are talking about the lungs. So first things first is you have to identify your PaCO2 because this value right here is the lungs. So let's here we have here the lungs, and this is the kidney, and pH is basically the blood, right? So there are two main organs in the ABG reading that you are going to consider, lungs and kidney. So for PaCO2, we have the lungs, right? So respiratory opposite, we are going to compare the arrows for the lungs and the blood, right? pH. And for the metabolic, since this is for the lungs and this is for the kidney. So kidney, we have your bicarb and your pH. So we are comparing. Now, as the mnemonic states opposite, it has to be an opposite. So it can be, we have here, this is arrow up, or the pH can be arrow down. So as you can see, the arrow is facing in the opposite direction, or it can be the PaCO2 can be arrow down, or the pH can be arrow up. So you can identify if this is present in your ABG result. So it means that it is considered as a respiratory problem. Now, if it's a metabolic problem, it has to be equal. So what do you mean by equal? So we have here the HCO3 is down, and then the pH is also down. That's equal. And another result would be up, bicarb is up, and then your pH is also up. So therefore, it is equal. So if your result shows these types of arrow, it is considered as a metabolic problem. All right. Now, number two. So we have to identify if it is respiratory or alkalosis. Now, first things first, you already know that if the problem is metabolic or respiratory. Now, in identifying if it is acidosis or alkalosis, you have to look at your problem. For example, I will give an example of the pH is 37.50, bicarb is we have 28, and then we have PaCO2 of let's say 20 um 28 also, right? So let's put in the arrow. This is arrow up, this is arrow up, and this is let's say this is arrow okay, so let's change this one. So let's make it simple, no? So this is 42, right? So this is arrow up, but this is considered as normal. All right. So now, first, your step one is you have to identify your row. So respiratory opposite, metabolic equal. So we're going to take a look at PaCO2 and then your pH. Then this one is your bicarb and then your pH. So our PaCO2 is arrow up, our pH is also arrow up. So it is not opposite. So this is not a respiratory problem. Now, our bicarb is up and then our pH is up. Therefore, this is a metabolic problem. So this is metabolic. So you already identified that this is metabolic. Now, in the second step, you have here is you focus now on the metabolic result because it is where the problem is at. So you take a look at the bicarb result, no? So bicarb is 28 and it is increased. Now, by nature, we have to understand that the nature of your blood or your solutes, no? So by nature, bicarb is, as you know, alkaline. And then on the other hand, PaCO2 or basically your carbon dioxide is acidic by nature, right? Because your your carbon dioxide is derived from your carbonic acid, which is an acid. Therefore, the more carbon dioxide, the more acidic, right? So same goes with bicarb. So if you remember that, that will be your guide in identifying your acidity or alkalinity. So in this step, I am not using pH to determine the acidity or alkalinity. I'm looking at the bicarb or the PaCO2 level, no? So I know that by nature bicarb is alkaline. My normal bicarb result is 22 to 26, right? So my result is 28. Therefore, I have more bicarb. So if I have more bicarb, so my bicarb is alkaline. So what is the result? It means that I have increased alkalinity in the blood. So it's alkalosis. All right? Alkalosis. Alkalosis. Okay? Because if the result is less than the normal value, no, less than 20, for example 20, the result is 20, therefore I have less bicarb, therefore the result tends to be acidic. Okay, so I hope you understand that. Now, same goes with your carbon dioxide or your PaCO2 level. So the more carbon dioxide, the more acidic. So the less carbon dioxide, the less acidic. So you just have to base your reading on the bicarb. So again, by nature, bicarb is alkaline. By nature, carbon dioxide is acidic. Therefore, the more bicarb, the more alkalosis or alkalotic. The less bicarb is acidosis. All right, acidosis. Now, with PaCO2, the more carbon dioxide, meaning acidosis, because by nature, carbon dioxide is acidosis. The less PaCO2, it is alkalosis. Because you know the nature of the values here, right? Now, so now we already identified. So this is alkalosis. So this is metabolic alkalosis, right? Now, next is identify if it's compensatory or uncompensatory. So in the number 3 step, we have to take a look at the other organ, because if it's compensating, therefore your other organ has to be compensating. Now, remember that there are only 2 organs that is involved here. You have your kidney and your lungs. So my organ that's that's having a problem is your metabolic or your kidney. Therefore, your kidney is having the problem. So what organ needs to compensate? It has to be your lungs. So you will have to take a look at your PaCO2 level. So take a look at, because the lungs will be responsible for compensating. Okay, so your PaCO2 level is, the normal value is 35 to 45. So the result that we have is 42, which is normal. So that is 42 increase, but it is normal. So therefore, if your, or if the organ that is compensating is supposed to be compensating is in a normal value, meaning the compensatory organ is not compensating, because it's not doing anything to compensate in the abnormality of your kidney. All right, do you understand? So normal value in the opposite organ means that it is uncompensatory. All right, so that's uncompensating. Now, if we change this to, let's say, 48 above, it's arrow up and it's abnormal. Now, the result will be different. 48 is above, it's abnormal. Now, you know that by nature, 48 carbon dioxide is more than the normal. And you know that carbon dioxide by nature is acidic. So there is more carbon dioxide in your body, so it wants to become acidic. All right, it wants to become acidic. So it's in an acidosis state. So it's compensating for the alkalinity of your kidney. All right. So now if the value is 48, right, is increased and abnormal, so it's now compensating. All right, compensating. So you now identify it as compensating. So you have your metabolic alkalosis, compensatory. No? So now the last step, since if it's compensating, you will go to step 4. It is if it is partial or fully. Now, your pH is 7.50. In identifying your partial or fully compensatory, you have to take a look at your pH. It's very simple. So your normal value is 7.35 to 7.45. If it is your pH is normal, then it is considered fully compensatory. If it's abnormal, then it is partial compensatory. Now, our result is 7.50, therefore it is partial. So your answer would be, in this problem, where is that? 7.50, 28, and 48. All right. So 7.50, 28, and 48. These are the results. So this is increase, increase, increase. So for this result, your answer would be metabolic alkalosis, partial compensatory, or any way that you want to write it down. All right. So, but mostly it's written like this: metabolic alkalosis, partial compensatory. Okay. So I hope you understood the 4 easy steps. Now let's try to answer an example. So we have here the steps in the sides to guide you, right? So try to answer this in your paper or in yourself. No? So you can pause the video so that we will not reveal the answer. So pause the video for a while, try to answer, and then we will start. I will start giving the answer. All right. Okay, so let's try to answer it. First is you have to identify if it's metabolic or respiratory. So let's put an arrow up, arrow down, and then we have arrow down. All right, so arrow up, arrow down. So remember your normal values, you have to memorize them. 7.35 to 7.45. We have 22 to 26. We have 35 to 45. No? So number one, so identify your room. So PaCO2 is arrow down. Then pH is arrow up. So it is respiratory. Check. Let's take a look at if it's metabolic. So bicarb is down. And then we have, excuse me. Again. So we have here down, up, down, up. Okay. So metabolic is the arrow down. And then we have pH is arrow up. Okay, so metabolic equal, no. So therefore, this is respiratory. All right, so this is a respiratory problem. Now, next, number two, we have to identify if it is alkalotic or acidotic. Now, what is the problem? Respiratory. So let's take a look at our PaCO2. So 30. So normal is 35. Therefore, I have a few carbon dioxide. By nature, I know carbon dioxide is acidic. So konti lang yung carbon dioxide ko. Therefore, it is alkalotic or alkalosis. Right? Then number three, we have to take a look at the counterpart. So this is the lungs. So the counterpart will be your kidney. So let's take a look at kidney. So kidney is or bicarb is 20. You know that by nature bicarb is alkaline. So kukunti lang din yung alkaline ko, right? So dahil konti lang yung alkaline ko or yung bicarb ko, it's trying to be acidic, all right? So therefore it is compensating. Compensatory. All right? Now, so if it's compensatory, let's go to number 4, 7.50. So is it normal, abnormal? This is abnormal. So therefore, this is partial. So respiratory alkalosis, compensatory, partial, or you can write it as partial compensatory. All right? Next, let's try to answer number 2. You can hit the pause button if you want. So you can answer on yourself. Hit the pause. Okay. Now let's try to answer. No? So we have here, let's write down the normal values. 35 to 7.45. We have 22 to 26. You have your 35 to 45. This is arrow up. This is arrow up. This is arrow down. So let's take a look. Number 1, our roam. So we have here PaCO2 up, pH down. Metabolic is bicarb is up, pH is down. So is it a metabolic problem? Is it equal? No. Is it opposite? Yes. Again, this is a respiratory problem. Now, number 2. So since this is a respiratory problem, let's take a look at PaCO2. 55 is the result. So 55 is very high, right? And by nature, you know that carbon dioxide is acidic. So therefore, marami ang kanyang carbon dioxide. That's why this is acidosis. All right. So this is an acidosis problem. Now, number 3, take a look at the counterpart organ, which is your bicarb. So bicarb is 30, which is increased. So you know that bicarb is alkaline by nature. So marami tayong bicarb, therefore your kidney is trying to be alkaline. So again, it is compensatory. And next, number 4, pH. What's your pH? 7.30. It's abnormal, therefore this is partial. All right, did you get the correct answer? Respiratory acidosis, partial compensatory. All right, now let's proceed to another question. So same pa rin. I know that you already understand this. So pause the video and answer on your own. And then we'll try to answer later. Okay, so let's write down the normal values. 7.35 to 7.45, 22 to 26. We have 35 to 45. So this is arrow down, this is arrow down, and this is arrow down, but is still normal. All right, number 1, ROME. So respiratory, so we have arrow down and arrow down. So metabolic, you have arrow down and arrow down. So is it respiratory? No, it's not. It's not opposite. Is it metabolic? Yes, because it is equal. So this is a metabolic problem. Right. Now let's take a look at number 2, your bicarb, because that's the problem. You have your kidney is the problem. So our result is 18. So the normal value is 22. So kukonti lang yung bicarb natin, and you know by nature bicarb is alkaline. So kung konti lang yung alkaline, anong tendency nito? Nagiging acidosis. All right? So this is metabolic acidosis. Now number 3, take a look at the counterpart, no, or your lungs. Kasi ang problema natin ng kidney, tingnan natin si lungs. Ano bang ginagawa ni lungs? 35, mababa pero normal. Ano nga yung ibig sabihin? Pag normal yung counterpart, ibig sabihin uncompensatory. So, this is metabolic acidosis, uncompensatory. Compensatory. Now, pag uncompensatory, hindi na tayo pupunta sa step number 4 kasi hindi naman natin kailangan malaman kung partial or fully kasi nga hindi na siya nagko-compensate. Alright? So, I hope nakuha niyo yung tamang sagot. So, let's proceed to the next question. So, same pa rin tayo. We have 7.35 to 7.45. Pause nyo lang, no, kung gusto niyo mag-answer. So, 22 to 26, 35 to 45. Now, this is arrow down. Bicarb is arrow down. This is arrow up. All right. So, number 1, ROME. So, respiratory opposite. So, PaCO2, arrow up, pH down. Me, down. Then pH is down. So, is it a respiratory problem? Yes. Is it a metabolic problem? Yes. So, ano ibig sabihin nito, sir? So, ibig sabihin, this is what you call mixed. No, mixed or some say combined. So, ibig sabihin, both metabolic and respiratory problem. So, kung titingnan mo number 2, kung anong problema? So, titingnan mo yung may problem. Ang dalawa naman yung may problem. So, usually, pag ganito ang problema, nag-i-in-sync yan sila. So, 53. So, bicarb is 16. Ibig sabihin, mababa. That's you're leaning towards acidosis. Kasi kukonti lang yung bicarb niya. Now, marami siyang carbon dioxide. So, ibig sabihin, acidosis pa rin. So, this is mixed or combined metabolic respiratory acidosis. So, sa mga ganitong cases, automatic ang number 3 nito is uncompensatory na automatic yan. So, for me, I don't need to put uncompensatory because automatic na yung pag-mix siya, wala talagang nagko-compensate sa kanila. No? But if sabihin ng teacher ninyo or merong nakalagay sa choices na uncompensatory, so pwede naman din, but it's already parang common sense na pag-mix siya, wala talagang nagko-compensate sa kanila. Alright? So that's the answer for this question. Alright, let's take a look at the next one. So I think this is the last question. So type pause if you want to answer this one. And hit play if you want to see the results. Okay, so let's write in the values 7.35 to 7.45, 22 to 26. We have 35 to 45. So we have arrow up, arrow up, arrow down. All right, number 1, ROME. So respiratory PaCO2 is down. This is up. Metabolic is up, then up. So again, is a respiratory problem? Yes. It's a metabolic problem? Yes. Again, this is mixed or combined metabolic and respiratory problem. Now, acidotic or alkaline. So, tingnan natin yung may problem. Sila dalawa naman yung may problem. So, 55 and then 25. So, we have here, increase ang bicarb. Therefore, it is going to be alkalosis. And then, 25 naman ang carbon dioxide. So, kukunti lang yung carbon dioxide natin. So, it's tending to be, it's tending to be alkalosis pa rin, di ba? Kasi by nature, you know that carbon dioxide is acidic. So dahil konti lang yung carbon dioxide mo, so alkalosis. So again, alkalosis. Alkalosis. So we have mixed or combined metabolic respiratory alkalosis. So automatic na yan, uncompensating. Alright, so that's the answer for this question. So I hope na nakuha nyo yun at nakatulong sa inyo. So if you find this video helpful, please like, share, and subscribe. And thank you for your support. God bless.